Linux just got a feature that changes everything, and if you've been even slightly paying attention to the world of operating systems, you already know that when something big happens in Linux, it doesn't just affect hobbyists or programmers sitting in dark rooms. It affects servers that run the internet. It affects Android phones. It affects cloud infrastructure. It affects supercomputers. And increasingly, it affects everyday desktop users. This new feature isn't just another incremental update. It represents a philosophical shift, a technical breakthrough, and potentially a turning point in how people think about Linux as a platform. For years, Linux has been known for stability, flexibility, security, and control. But it has also been criticized for fragmentation, hardware compatibility issues, and sometimes a steep learning curve for newcomers. Now, with this new feature rolling out across major distributions, those long-standing criticisms are being challenged in a way we haven't seen before. To understand why this matters, we need to step back and look at how Linux traditionally works. At its core, Linux is built around a monolithic kernel design, meaning that most system services run in kernel space, giving them direct access to hardware and system resources. This design is incredibly efficient and fast, which is one reason Linux dominates servers and high-performance computing. But it also means that updating core components often requires careful coordination. Drivers, kernel modules, and system libraries all need to align properly. Traditionally, updating the kernel meant rebooting the system. For servers, that could mean downtime. For desktop users, that could mean interrupting work. For mission-critical infrastructure, even a few seconds of downtime can be costly. The feature that is now changing everything is live kernel patching becoming mainstream and deeply integrated across distributions, combined with a new generation of atomic updates and immutable system designs. While live patching has technically existed for years in enterprise environments, it has now matured to a point where it is becoming accessible, reliable, and standardized across mainstream Linux distributions. This means that critical security patches and kernel updates can now be applied without rebooting the system. Imagine your operating system updating itself at its deepest level without forcing you to stop what you're doing. That's not just convenient, it's transformative. For enterprise environments, this is a massive shift. Traditionally, system administrators would schedule maintenance windows to apply kernel updates. Even with redundancy and load balancing, there was always complexity involved. Now, with live kernel patching integrated into major distributions, security vulnerabilities can be patched in real time. Zero-day exploits can be addressed immediately. Servers can maintain uptime measured in months or even years without interruption. This drastically reduces risk and operational cost. In a world where cybersecurity threats evolve daily, the ability to patch a running kernel without downtime is a game changer. But the impact doesn't stop at servers. On the desktop side, we're seeing the rise of immutable Linux distributions that use atomic update systems. Instead of modifying the system piece by piece, updates are delivered as complete images. The system essentially swaps to a new version in a single atomic operation. If something goes wrong, it can instantly roll back to the previous state. This approach is inspired by container technology and mobile operating systems, and it brings a new level of reliability to Linux desktops. No more broken updates that leave you with a black screen. No more dependency conflicts that corrupt your environment. The system becomes resilient by design. This combination of live kernel patching and atomic image-based updates is reshaping how Linux is perceived. For decades, Linux was powerful but sometimes fragile in the hands of beginners. Now, it is becoming both powerful and robust in a way that rivals or even surpasses proprietary systems. The user no longer needs to worry about whether an update will break Wi-Fi drivers or graphics support. The system architecture itself minimizes those risks. Another key component of this transformative shift is improved hardware enablement and driver integration. The Linux community has made major strides in working directly with hardware manufacturers. Graphics drivers, especially for modern GPUs, have seen dramatic improvements. Technologies like Wayland have matured, providing smoother graphics performance and better security isolation compared to older display servers. With modern kernel features, hardware support is increasingly For many users, installing Linux no longer means hunting for drivers or tweaking configuration files. It goes to works. Security is another area where this new feature set changes everything. Traditional Linux security already included robust permission models, Linux or Parmer confinement, and open source transparency. But now, With live patching and immutable system layers, the attack surface is reduced even further. Because the base system is read-only in many immutable distributions, malware cannot highly modify core components. Even if something compromises user space, the underlying system image remains intact. Rebooting effectively restores a known good state. Combined with containerization and sandboxing technologies like Flatpak and Snap, applications are increasingly isolated from the core system and from each other. This architectural evolution also aligns Linux more closely with cloud-native computing. In the cloud world, infrastructure is often treated as disposable. Systems are spun up and torn down dynamically. Immutable images and containerized workloads are standard practice. By bringing similar principles to the desktop and traditional server environments, Linux is unifying its ecosystem. Developers can build applications in containers, test them in immutable desktop environments, and deploy them to cloud servers running the same underlying technologies. The consistency reduces friction across the entire software lifecycle. Performance is another area where this shift matters. Live kernel patching mechanisms are designed to apply minimal changes to running systems. They carefully redirect function calls and patch memory structures without disrupting ongoing processes. This requires advanced engineering and deep knowledge of kernel internals. The result is not just convenience, but efficiency. Systems can remain optimized and responsive while being updated. There is no lengthy boot sequence interrupting workflows. For industries that rely on real-time processing, such as finance or telecommunications, this continuity is invaluable. In the past, live patching was often locked behind enterprise subscriptions. Now, community distributions are incorporating similar capabilities. The technology is no longer reserved for large corporations with dedicated IT teams. Small businesses, independent developers, and even home users can benefit. This democratization of advanced system management tools reflects the core philosophy of open source. Powerful technology should be available to everyone. We're also seeing integration with modern boot technologies, like systemed enhancements and unified kernel images. These developments streamline how the system boots and manages services, combined with secure boot support and measured boot processes. Linux systems can verify their integrity from the moment they power on. This creates a chain of trust that enhances security without sacrificing flexibility. Users can still customize their systems, but the foundation is more secure and reliable. The psychological impact of this feature cannot be ignored. For years, one of the arguments against switching to Linux on the desktop was fear of instability or complexity. When users hear that the system can update itself at the kernel level without rebooting and can roll back instantly if something fails, it changes perception. It positions Linux not as a risky alternative, but as a cutting-edge platform. This shift in perception could accelerate adoption in schools, businesses, and government institutions. Developers also benefit enormously. Kernel developers can deploy critical fixes faster and with greater confidence. Distribution maintainers can push updates without worrying as much about breaking user systems. The feedback loop becomes tighter. Security researchers can see vulnerabilities addressed in real time. This responsiveness strengthens the entire ecosystem. There is also an environmental angle. Data centers consume vast amounts of energy. Rebooting thousands of servers for routine updates consumes additional power and can reduce hardware lifespan due to thermal cycling. By minimizing reboots, live patching contributes to energy efficiency and hardware longevity. While the impact per machine may seem small, at scale, it becomes significant. Education and experimentation become easier as well. Because immutable systems allow safe rollbacks, users can experiment without fear. Want to try a new desktop environment or a system configuration? If something goes wrong, you can revert. This encourages learning and innovation. It lowers the barrier to entry for people curious about Linux, but hesitant to risk their primary machine. As we look forward, this feature lays the groundwork for even more ambitious changes. Imagine AI-driven system optimization that patches and tunes the kernel dynamically based on workload patterns. Imagine seamless transitions between hardware devices, where your Linux environment follows you from desktop to laptop to cloud instance, with identical configuration integrity. The foundation being built now makes those possibilities more realistic. Critics might argue that Linux has always had advanced features, and that this is just another incremental improvement. But history shows that certain technical evolutions mark turning points. The introduction of package managers simplified software installation. The rise of graphical desktop environments broadened appeal. The integration of containerization revolutionized deployment. In the same way, mainstream live kernel patching and atomic system updates represent a structural evolution. They address long-standing pain points while preserving the strengths that made Linux dominant in the first place. The open-source community deserves credit for this progress. Thousands of contributors collaborate across continents, refining kernel code, testing patches, documenting processes, and building tools that make these features usable. Unlike proprietary systems, where innovation happens behind closed doors, Linux evolves transparently. Anyone can inspect the code, propose improvements, or adapt it for specialized needs. This transparency builds trust and resilience. For everyday users, the change might initially feel subtle. Your system updates quietly in the background. You don't see a forced restart. You don't encounter sudden downtime. But over time, that reliability builds confidence. You begin to realize that your operating system is not just functional, but robust and self-healing in many ways. That experience shapes how people talk about Linux and recommend it to others. In developing regions and emerging markets, where access to reliable infrastructure can be limited, the ability to maintain secure, stable systems without complex maintenance procedures is invaluable. Schools, small businesses, and community organizations can deploy Linux systems that stay secure and functional with minimal oversight. This empowers digital growth and reduces dependency on expensive proprietary solutions. Ultimately, what makes this feature transformative is not just the technical mechanism of patching or atomic swapping. It is the philosophy behind it. Resilience by design, security without disruption, power without fragility. Linux has always been about giving users control. Now it is also about giving them a peace of mind. The system can adapt and protect itself in ways that were once considered enterprise luxuries. We are witnessing a convergence of ideas from servers, cloud infrastructure, mobile operating systems, and desktop computing. Linux sits at the center of this convergence. By adopting live kernel patching as a mainstream capability and embracing immutable atomic system updates, it bridges worlds that were once separate. The same principles that keep cloud servers running 24/7 now protect personal laptops. The same atomic reliability that powers containerized microservices now safeguards everyday applications. Linux just got a feature that changes everything, not because it alters the fundamental nature of open source, but because it refines it. It strengthens the core while smoothing the edges. It preserves freedom while enhancing stability, and in doing so, it positions Linux not just as an alternative operating system, but as a forward-looking platform ready for the next decade of computing.